This podcast continues our series in the lymphoid system. We're dealing with the lymphoid organs now, and here we're going to be talking about lymph nodes. Lymph nodes are encapsulated organs, and you may remember from gross anatomy they're found throughout the body. There is a connective tissue capsule around lymph nodes, and the connective tissue capsule penetrates the organ incompletely, so some septa from the capsule penetrate the organ a little bit. Characteristics for lymph nodes: you can see afferent lymphatic vessels all around the periphery of the node. These drain into a subcapsular sinus. The subcapsular sinus is continuous with a trabecular or intermediate sinus, and these sinuses are continuous with the medullary sinuses. So afferent vessels all around the periphery of the node, and then at the hilus of the node is usually a single efferent lymphatic vessel that drains lymph from the node. You can look at lymph nodes and define a cortex and a medulla. The cortex is a region that has lymph nodules, and the medulla does not have the lymph nodules. If you look at a lymph node this way, the diagram on the left looks at the filtering function of lymph nodes with relation to lymph flow, and the diagram on the right looks at the blood circulatory function of lymph nodes with respect to blood flow. So let's look at the diagram on the left first. Here you would have the afferent lymphatic vessels that would come into the node, and then the efferent vessel draining the node. Now lymph would come into this afferent vessel and would make its way into the subcapsular sinus, the trabecular sinus, and the medullary sinuses, and would flow out through the efferent lymphatic vessel. On the other hand, lymph might also come in through the afferent vessel, and rather than going through the sinuses, the lymph fluid might actually percolate through the parenchyma of the lymph node and then slowly drain its way through to the medullary sinuses. And this percolation through the parenchyma of the node is how the lymph node filters lymph fluid. The lymph nodules are found in the outer cortex of the lymph node. You can see them on the diagram here or on the diagram here. And the lymph nodules within a lymph node are sites where B cells mature to plasma cells or to B memory cells. Lymph nodules can either be primary or secondary. A primary lymph nodule would have B cells that are in a resting or quiescent states. They would be cells that are in either G sub 0 or G1 of the cell cycle. On the other hand, lymph nodules within the node would be secondary nodules. They would have what are called germinal centers. They'd be actively dividing cells, and you would find these secondary nodules in lymph nodes from individuals who have had an immunologic challenge or insult, if you want, and the B lymphocytes in the node are responding. They're dividing and would be actively differentiating into plasma cells or to B memory cells. The inner cortex of a lymph node would be deeper than the area where the nodules are. There would be no nodules there. That would be an area where there are T cells. So the inner cortex of a lymph node is considered a thymic dependent area. And as we said, that contains the T cells. Now, if we look at the blood flow coming into the node, here would be the artery coming in, and notice that you have this capillary plexus that encircles the lymph nodules. And then there are structures that are called post-capillary venules that are going to turn out to be very important to allow lymphocytes to home into the lymph nodes. These post-capillary venules, they're within the inner cortex, and the endothelium on these post-capillary venules is rather unusual. We call the endothelial cells high endothelial cells, and these are the areas that allow T lymphocytes to home in on the lymph nodes. It turns out that the T cells express L-selectins, whereas the endothelial cells express E and P selectins and various chemokines, and these selectins and chemokines play a critical role in allowing the T cells to actually home in to these areas in the lymph node. Lymphocyte homing and diapedesis works sort of as described on this diagram. The T cells will express L-selectins to bind to lecithins on the endothelial cells, and this allows the cells to move through these capillaries, and they'll roll along and slow down when they get to the sites where the endothelial cells are expressing E and P selectins. The endothelial E and P selectins will bind onto the lecithins on the T cells. That will allow them to slow down, and then diapedesis will begin. And diapedesis is basically a situation where the T lymphocyte is squeezing its way through the high endothelial cells in these post-capillary venules. And this diagram, or actually this micrograph, shows the process. Note the cuboidal nature of these high endothelial cells. Notice this endothelium is not a typical squamous appearance. Rather, it is almost a very cuboidal nature. And then here you can see the lymphocytes that are squeezing their way through these endothelial cells. So as you would imagine, these lymphocytes are getting out of the blood circulation here and getting into the parenchyma of the lymph node. So if I go back a couple of slides, these T cells are coming out of the blood vessels here and are getting into these thymic-dependent areas within the lymph node. Lymph nodes act as a filter because there are dendritic cells in the stroma, and this just is an artist's conception of what these dendritic cells might look like. Here would be lymphocytes that are embedded in long projections of these stromal cells, and this filter, as you might imagine, can get overwhelmed, and as it gets overwhelmed, it gets clogged up, and that does play a certain role in metastasis of tumors, because as the tumor cells clogging up this node, they almost overwhelm the system, and then they can move to a node downstream. Some of these dendritic cells, they're also given the name follicular dendritic cells, retain antigens on their surface for very long periods of time. Others of these dendritic cells are very efficient as antigen-presenting cells, displaying both MHC1 and MHC2 molecules on their cell surfaces. If you look at the circulation of lymph, we realize that lymph moves both fluid and cells, and lymphocytes enter lymph nodes by two routes. The afferent lymphatic vessels, which primarily allow B cells to get into the lymph nodes, and then post-capillary venules primarily allow T cells to get into the lymph node, and these T cells are for immunologic surveillance. So the diagram would show this. Here the afferent vessel with lymph fluid coming into the node, and the lymph fluid would of course be carrying lymphocytes, and then the blood is clearly carrying lymphocytes, and here the lymphocytes are entering through these post-capillary venules. And the point I'd like to make here, about 70 to 80% of the circulating lymphocytes in peripheral blood are T cells, and these are the cells that are involved in immunologic surveillance. This diagram just highlights blood flow and lymph fluid flow through a lymph node in relation to the delivery of lymphocytes to the node. 90% or so of the flow through a lymph node is blood, and that is mostly delivering T cells. About 10% of the flow through the lymph node is lymph fluid, and that's mostly B cells. Here on the right part of the diagram, the artist is just showing this, the green arrows showing lymph flow through the node, through the afferent vessels, carrying mostly B cells, and then the blue arrows, blood flow coming from these post-capillary venules with the high endothelial cells, and this blood flow carrying mostly T cells. this is just a histological view of the lymph node. You can see the lymph node here in very low power, cortex, medulla. There is a connective tissue capsule around the node. Here you can see actually lymph nodules, and these would be the germinal centers, the clearer area. I'm tracing a nodule like this, another nodule like this, and maybe another nodule like this, and the clear area or germinal center would suggest that the B cells in these nodules are actively dividing, actively making antibody and differentiating into plasma cells. And this is just a little bit higher power view of the nodule, and you might even get a sense potentially of seeing some mitotic figures. Note the connective tissue capsule here. Note the capsule incompletely penetrating the organ as trabecula coming down into the organ. Here you can see a little bit of the subcapsular sinus, a little bit of the trabecular sinus here, and some medullary sinuses. Now in the laboratory we will show you many more views of the lymph nodes.